Hello and welcome back. My name is Tarmo Ramel and I am going to provide the second tutorial in the series about using the Smart GeoFill tool in PCI Geomatica Banff. In the past tutorial, we looked at replacing cloud and shadow contaminated pixels with likely candidate values from within the same scene. Today, we're going to look at a similar functionality, but we're going to pull in quote-unquote clean pixels from an adjacent image in time where we don't have cloud to replace the pixels in the current image that are clouded or shadowed. So I have two images of Hawaii. I'm going to bring both of them in. There's the first one and here's the second one. So I realize that they might not be showing in the best possible way, so I'm going to go in and make these false color infrared. Let's zoom in on this part of Hawaii here, and we have here an image that is got a streak of clouds running through it. I'm going to be working with trying to reduce the effect of these clouds. So let's keep things a little bit easier to remember. And I'm going to rename this image Cloudy Hawaii. And then I'm going to look at this version, 5.4.3. This one here is, let's call it cloud-free, although it's not totally. Cloud-free Hawaii. So that when we look at these two images, we can see cloud-free, cloudy, cloud-free, cloudy. Okay, so we're going to try to fix some of this by replacing those contaminated pixels from the non-cloudy version. So the cloudy image is from the 19th of September 2020, and the cloud-free version is from the 8th of October 2020. So they're pretty close in time, which means that the ground conditions should be relatively representative of one another, particularly in this region where the seasonality effect isn't quite as strong. So we're going to start by making sure that the pencil, the editing is happening on the cloudy Hawaii version. And then we're going to go up to Tools and select Smart GeoFill. I'm going to slide this window up to the top just so that it's a little bit out of the way. I'm going to ensure that we select by polygon, and we're not going to do all of the clouds in this image. This could be an iterative step-by-step doing piece by piece, but let's go in and just choose one section and work with it for now. I'm going to draw a polygon through here. Oops. I turned off the polygon drawing tool. We'll turn it back on and we'll go in here and we'll select a region that we want to replace. So notice that we have this dotted blue line that delineates the area that we want to actually replace the cloud and the shadow in. And rather than selecting output, which what we were using before, when we would simply drag this polygon to a new location, we're going to change the source to be from the project file set, because my clean or cloud-free Hawaii image is already open in the viewer. And as I do that, instantly the clean pixels from the cloud-free image have been pulled out and dropped into the cloudy Hawaii version, and you can see that they are indeed gone. We can click on the source visibility, and we can see where they were, click back and forth, and say, yes, it's definitely replacing those contaminated pixels with something that's cleaner. We can remove the boundary, and you see that it looks really quite good. We could always add a blend if we wanted to sort of blend over a larger larger distance. But we should also click on the automatically apply color balancing. It ensures that the color tones across the image are maintained. So now if I turn the boundaries off, it looks like nothing has actually been done to this image. It looks absolutely incredible. If we're happy with the results, we can paste them to the file, and we can then remove the selection set so that we get rid of that polygon. We can move on to a different region and work with it. So we could then pan to a different part of the image, and we could maybe work with these or these clouds and keep iterative cleaning them up. So let's do that. Let's select these clouds right here, and boom, they're gone. They look really good. We don't need to blend any long distances. We seem to be happy with the way that worked. We can paste those to the file and then move on to another area. So maybe we'll go up over here. It's maybe a little bit too zoomed in. Let's see if we can get rid of some of these clouds in here. And notice that the clouds have been replaced, but these ones here have shown up. So the cloud-free Hawaii image had small amounts of cloud in this region, and it replaced those in. We want to make sure that we don't do that. If we go back and we look at the source visibility, we would have been better to keep some of those pixels in this central region from the actual cloudy imagery. So we want to be really sure that we're picking regions that don't now start to introduce new contamination into them. Really sort of an iterative process. Okay, maybe we won't do these ones. We'll leave those and we'll do them small piece by piece as we move on. So as we think about using Smart GeoFill, we need to make sure that we're very specific in identifying the areas that we want to actually improve, and to make sure that where we're drawing pixels in from, that those aren't contaminated as well. So it's possible to go into a series where we have multiple different images bringing clean pixels into the final destination. But this tool allows us to now have, or the ability to make, relatively cloud-free representations, which is quite nice. And then when we're done, when we hit close, we can save the results to the final file. And then when we move on to do something like an image classification, we're not going to have these clouds that are getting in the way. But we do need to keep in mind that the values of the pixels might not be from the exact time period that the original file was from. So some files that are side by side, adjacent in geographic space, may actually be separated by time in terms of when they were acquired. So the interpretation of your data will be slightly altered based on this replacement of contaminated pixels. Anyhow, happy remote sensing, and we'll talk to you next time.